We've all kind of bought into the same story about AI, right? To get smarter models, you need more data, way more computing power, and honestly, just a ton of money. But what if that's not the whole picture? What if the AI models we already have are, like, secretly brilliant, and we've just been asking them questions the wrong way? Today, we're diving into some really groundbreaking research that might just flip everything we thought we knew about AI on its head.
And this, right here, this is the big question. I mean, we are deep in an AI arms race. You've got companies spending absolute fortunes to build bigger and better models. But what if everyone's looking in the wrong direction? What if the key isn't building a bigger brain, but just learning how to use the brain we've already got, but, more effectively?
So the clues to this whole mystery come from a new research paper that is making some serious waves. It's one of those papers that suggests we can get these incredible top-of-the-line results without all the super expensive retraining we've all just come to accept as necessary. Let's break down how they actually figured this out.
Okay, so how do we currently make an AI smart? Well, the secret sauce for today's best models, especially the ones that are just wizards at complex math and coding, is a process called reinforcement learning. You'll hear it called RL for short.
And this is the absolute core of their investigation. Is RL fundamentally adding new knowledge, new skills to the AI? Or is it more like a really tough coach that's just sharpening the model's existing abilities, forcing it to pick the best possible reasoning paths that it was actually capable of finding all along? It's really a question of learning versus unlocking.
So if RL is the reigning champion of AI training, why would we even be looking for an alternative? Well, it turns out that even champions have their weaknesses. And for RL, those weaknesses, they're pretty significant.
First, just a quick refresher on how this stuff works. Reinforcement learning is basically about giving the AI a little digital reward for a correct answer. Think of it exactly like training a dog with treats. You do this millions of times, and the AI starts to learn which patterns of thinking lead to a reward, and it begins to favor them. Simple, right?
Well, here's the catch. This process is an absolute beast to manage. It's insanely expensive, it's super complex, and it has this really sneaky side effect called mode collapse. Imagine this. You ask an AI for a new creative recipe, and it only ever gives you different kinds of chocolate cake. Why? Because it learned that chocolate cake is a safe answer that always gets a reward. That's mode collapse. It totally stifles creativity and locks the AI into just one way of thinking.
So if RL is the costly champion, these researchers proposed a brand new training-free challenger. It's a technique that works at inference time called power sampling. So instead of retraining the model for months, it just changes how we ask for an answer in the moment.
Now, what's so cool about this slide is how it frames the difference. Think about solving a maze. Standard or greedy sampling is like looking down at your feet and just taking the path that seems widest at every single turn. You might get lucky, but you could easily get stuck. Power sampling, on the other hand, is like sending a drone up to map out all the possible paths to the exit first and then choosing the first step of what you know is the absolute best route. It plans ahead.
And it does this through this really clever iterative process. So first, the base model just spits out a full, complete answer. Then it goes back and repeatedly refines little parts of that answer, over and over. And here's the key. It only keeps the changes that make the entire answer, from beginning to end, more probable or more coherent. It's like it's drafting and editing an essay on the fly, constantly tweaking until it finds the most logical argument.
And here is the kicker. This all happens at inference time. That means it happens right when you ask the question. There's no expensive, time-consuming retraining pipeline. You just use the off-the-shelf base model and spend a little more compute time on the query itself. That's it.
Okay, let's get to the results. Let's see how this new challenger actually performed against the reigning champ, RL. And I gotta say, the findings are pretty remarkable.
So on a competition-level math test, one that the RL model was specifically trained for, just look at this. The base model by itself gets about 50% right. The specialized RL-trained model gets up to 78.5%. But power sampling with zero training boosts the base model's performance all the way up to almost 75%. It almost completely closes that gap just by thinking harder.
And this just brilliantly illustrates the power of this approach. When they tested it on a task it wasn't trained for, in this case a coding challenge, the power sampling method actually outperforms the specialized RL model. See, the RL training made the model a math specialist, but it seems it forgot some of its other skills. Power sampling just unlocked the base model's more general, latent coding abilities that were there the whole time.
So, okay,
Power sampling is accurate, but is it creative? Does it fall into that same mode collapse trap as RL, where it just gives you the same answer over and over again? Well, the researchers had a really clever way to test for this, using a metric called PASIT-K. So think of PASIT-K as a test of creativity. You ask the AI for a whole bunch of different answers to the same question. If even one of those answers is right, it gets a passing grade. A truly creative AI will give you lots of different correct answers, so its score is going to keep going up the more attempts you give it.
And just look at this table. For one single attempt, yeah, the RL model's a little bit better. But as you give them more tries, the RL model's performance totally flattens out. It's just giving you slight variations of the same answer. Power sampling, though, keeps finding new, creative, and correct solutions. By the time you get to 16 attempts, its accuracy has climbed all the way to 90%, just blowing past the RL model. It completely avoids that diversity collapse.
So here's the crucial point. This isn't just some clever trick. It really suggests a fundamentally different and maybe a much more efficient direction for how we develop AI.
I mean, let's just recap the advantages here. It's training-free, which means you can use the base model directly. It's dataset-free and verifier-free, which gets rid of two of the absolute biggest headaches in RL. What all of this means is that high-level AI reasoning could become so much more accessible. It could really democratize access to these incredibly powerful capabilities.
The paper's authors really put it perfectly. They said, our base models are just much smarter than our current methods of talking to them, even reveal. It's like we've been so focused on building a better student, when maybe what we really needed to do was become a better teacher.
So, where do we go from here? This research isn't just a technical breakthrough, it's a real shift in perspective. It's about moving from a world of brute force training to one of intelligent, careful conversation with our AI. Which really leaves us with one final thought. If the genius is already baked into these models, just waiting for us to unlock it by asking in a smarter way, what's the most important problem we should point it at? What complex challenge in science or medicine or art could be solved not by years of more training, but maybe by just a few moments of deeper thought? Let us know what you think.